Our first structural pattern is the adapter pattern. The classic physical analogy is when you have an electrical outlet and you've gone to a foreign country, and sometimes you need a converter or an adapter to fit in that foreign country's sockets, because some of them are 50 Hertz and the US is 60 Hertz. So depending on which way you're going, you may need to go from 50 to 60 or 60 to 50. The adapter pattern is similar in that respect, in that you need to adapt one type of class into another type of class. So you've got an object that needs converting, and needs converting to a different type because that's what the rest of your application needs. But the types are likely similar. Obviously, you're not going to be converting a cat to a fire hydrant. One example of this is data transfer objects, or DTOs, to business objects. A data transfer object is often some kind of data that comes from a web service, and it will need conversion into the business objects that the rest of your application uses. Another possibility are third-party objects. Your application may collect data from multiple sources. Perhaps you're collecting a lot of users or a lot of customer names, but all these third-party objects come in different forms, and they need to be converted into a common form so you can aggregate them and use them together. So the adapter pattern provides an interface that the application is going to use, and the interface has the methods that the adapter will implement. The adapter class that implements that interface does the conversion. So it will do the conversion of different object types. In our examples, we've kind of focused on data classes, but the object types can be methods as well. So it doesn't have to be just a data storage class that we're converting using the adapter. It can also be any kind of class, and that class can be more focused on method implementations than it is on data properties. It doesn't really matter in terms of what the adapter does. The adapter just needs to be able to convert from one class type to another. Here's our example. We need a customer business object, and that's what's used throughout our application. We have a customer data transfer object, and it comes from a web service. Its properties are different than our business object customer's properties. Not tremendously different, just different enough that we can't use the DTO throughout the application. And we may have other customer DTO types that come in from other sources that we have to aggregate and put together as a single customer type. So in our example, we'll have an iCustomer list. And this is going to be the interface that the application uses. It'll have a getCustomers method, and that will return a list of business object customers. It'll also have an addCustomer method, and that will take a customer DTO parameter. In the implementation of the addCustomer method, it'll convert the customer DTO to a customer and add it to the customer's list that will end up being returned by getCustomers. So that interface essentially has two ends. On one end, the application is using getCustomers to get a list of business object customers. On the other end, we're using the addCustomer method to take a customer DTO and convert it over. So in our actual implementation classes, we'll just call that customer adapter. It implements getCustomers and addCustomer. In our class diagram, you can see on the left, we have our customer business object, and it has properties for address, city, customer ID, name, state, and zip. On the right, we have our customer DTO object, and it has properties for address, city, and then it has first name and last name as opposed to a single property for name. It has ID instead of customer ID, and it more correctly uses postal code as opposed to zip. So there are some differences, although those two objects are very similar. And the customer adapter class implements iCustomerList. It has an internal field, a list of customers, and those customers are of the business object customer type. And then it has the two methods that we talked about, addCustomer and getCustomers. So that's the adapter, and as you can see, structurally it's pretty simple. It's basically only going to be a single class that implements an interface. But of course, depending on the types of classes that it needs to adapt, and the complexity in terms of converting them from one to the other, the actual customer adapter class, or any adapter class, may be a little bit more complicated than it looks like on this diagram.